Hi, Matt. Can we move a meeting probably 1 or 2 hours before? Because it's very late in my time zone.
Yeah, unfortunately, there are a few folks in you're in like Eastern Europe sort of time zone, and then there's also a few folks who are in Asia time zone, and there's really no time that works. Yeah, hey Jürgen, that works well for both of them.
Okay, I have a GMT +3 time zone near Europe, and it will be probably a little better move time for meeting in 2 hours.
2 hours earlier, you're saying, right?
Yeah.
Yeah, I think maybe what we should look at is doing different times, like alternating between a couple times, so that folks it's reasonable for folks in Eastern Europe sometimes, and it's reasonable for folks in Asia sometimes.
Yeah, that sounds fair.
So like, maybe we do it 2 hours earlier than this sometimes, and then we do like maybe 1 hour later than this sometimes, which might be workable, although that's getting a little bit late for folks in the East Coast of the United States.
Hey, Matt, are these recorded anywhere?
Yeah, they are.
Can you post a link somewhere, maybe in the Slack channel or something?
They just go up on the YouTube channel, the OpenZFS YouTube channel.
Yeah, it's on YouTube, and it's also on the in the agenda doc. So like in the agenda document, if you scroll down to the previous meeting section, there's meeting notes and then links to each of the recordings from the previous meetings.
Got it. Thank you.
Okay, it's 1 after the hour. Let's get started. So we had a very, I think, good and productive discussion last week last month that kind of centered around the organization and what are the goals? Do we all have the same sort of goals? And hopefully we're on the same page with that. I'm not really looking to rediscuss that this time, but we can continue that on the mailing list if folks want to, or potentially at future meetings. We're pretty behind on technical items that folks wanted to discuss, so I'd like to make sure that we stick to getting through the items that are on the agenda this week. And if there's time at the end, then we can go off script. But let's get started with the sharenfs property compatibility stuff. I think George has wanted to bring up a problem and get input on what's the right way to address it.
Yeah, thanks, Matt. So yeah, one of the things that we've kind of been wanting to start a discussion about is how are people really using the sharenfs property? I mean, when we originally implemented this in Solaris, it was very closely tied to like the Solaris NFS sharing functionality, and it's probably worth noting too, sharenfs is not the kind of the only property. We also have like share iSCSI, which has been kind of dead as far as I know on most platforms, and like share SMB might also have similar issues. But the idea that I wanted to kind of get some thoughts around is this is like an on-disk component. And so how does this behave when you have to do like portable pools, as we've discussed on the mailing alias? What's the impact now when you try to bring in a pool that has some sharenfs setting that doesn't make sense on the platform you're trying to import on? And is that a concern for the community? Is this something that we should look at ways to try to come up with like some compatibility layer? Like Linux, for example, has kind of chosen to try to mimic some of the options that were available in Lumos, but I think like FreeBSD has kind of gone very specific to their implementation. There's downsides, I think, to each of these. So I kind of wanted to see how people felt, how people are using it. Are people using it? I think is probably another question.
George, is it fair to say that there's like a tension between basically having this just be like a pass through to the platform specific, NFS sharing functionality versus which is like easy to implement but not portable, and that on one side, and then on the other side, like having something that is really ZFS specific that each platform needs to like decode and do on their own platform, and maybe the list of available things like ZFS, NFS share things is like a subset of what's available on your platform, or maybe it's like you can't translate some things to your platform, or that's kind of the two of the things that you're considering, right?
Yeah, I think that's a very good way to kind of define the range of everything from like everybody kind of implements some specification, and maybe it doesn't cover every NFS option, so maybe it's for like we try to solve 80% of the use cases out there that kind of make it functional, but there might be somewhere you can't use the sharenfs property, or maybe there's some things that don't map correctly to certain platforms. I think there's a lot of investigation that we would have to do. So that's if we kind of went down the generic path, or we say it's kind of a free-for-all, everybody implements their platform component, but now we need to make ZFS smart enough that if you do import this on another pool, that like it knows how to deal with these properties and kind of does the right thing, or detects it. Like I can import the pool, but I'm obviously not doing anything beyond that.
You could imagine like actually having a like share NFS Illumos property, share NFS Linux property, share NFS FreeBSD property, because the property value is actually specific to that platform in terms of how it's interpreted.
You could presumably also store a shadow property that contains, say, the uname value at the time that the property was set, because presumably it made sense when it was set, and then if the uname doesn't match at import time, you'd, I don't know, print a warning, but not then apply the rules.
Yeah. So we probably don't want to get too far into the like how would we implement that. I mean, unless there's kind of until we have a consensus around which approach is the right one. So sorry if I kind of.
I think more universal can be better because we are using automation tools. And if you want to migrate a pool between platforms, you have to know what properties you are using on platform, and specify more universal rules will be much more better for transparent migration.
Matt, you asked how many people are actually using this. It would be great to have data on that. And I'm curious, should this be a responsibility of the file system?
I think that the integration, because you when you manage the file system with the ZFS commands today, the tree structure affords you the propagation of your assumptions down the tree, basically. And I think that makes sense for shared NFS 2.
And like with NFS v4 on FreeBSD, it works quite nicely. You just set the route you're going to share it, and then just have share NFS on or off to mask data sets. But with v3 on FreeBSD, yeah, you have, like George has in the doc there, and basically you have the entire line you would have put in your exports file, except for the path, as the contents of the property. And on FreeBSD, it's done very cheesily. It's literally writing that line into a text file that's basically appended to etc exports, except for it's a separate file, but our mount daemon knows to read etc exports and etc ZFS exports, which is just the share NFS property from every data set where it's not off concatenated to a file. It's really lame.
Yeah, and it doesn't always clean up after itself.
Yeah, it ends up being quite awkward too on Linux for those reasons, and flags that aren't yet supported, right? IPv6 is a good example of something that isn't really well handled. We also have the complication on Linux where you don't just necessarily have one NFS implementation or one Samba implementation. So which one are you talking about? Like which flag should it take? So I think there may be a good argument for not doing this in the file system too, or at least making it optional.
I have a question about this. Good, I can ask. Okay, so the specific about sharenfs, it seems to be very system specific, and I don't mean OS system, I mean actual environment specific. There is very little point to exporting that particular property to someone at another site. Is that correct?
I think it depends on your definition of site, right? Like, you could imagine having a pool that moves between systems within a data center. In that case, maybe you do want to continue providing those NFS services as you move it. But I think maybe what you're getting at is like some of the examples here where you're specifying what network, what subset of the network is allowed to access it, or with what privileges, and those don't make sense everywhere on the internet or in every computer that you could plug the pool into, for sure.
Okay, so my real question was, this particular and the share SMB one, I guess, are basically hints to the operators. So that kind of thing, whether something is a hint or an actual file system property, should impact how the various implementations are going to deal with it. That was my entire point.
So your point is that it should be a hint to the people who are operating it and not have any actual behavior in the system, kind of like a user property?
That is how I would say it should be described from OpenZFS perspective, yes. And then Linux or FreeBSD or macOS can decide how they're going to process it, if at all, on their side, if that makes any sense.
I can say, at least anecdotally, that we do not use I'm not even sure if NFS or SMB works on Linux, but we use both of those, and we just use the native tools in Linux, and we don't set anything having to do with the properties or anything like that.
From a FreeBSD standpoint and from a FreeNAS standpoint, it was always convenient to think of those properties as Solaris specific and to just pretend they didn't exist. It didn't do anything on FreeBSD, even though after a while they did start to do something. It was just easier to ignore them.
But they're definitely used on FreeBSD for NFS. The SMB one has never worked, and the iSCSI one has never worked. But
well, they
the
do
NFS
now.
one is.
Yeah, they do now. But when ZFS was originally ported to FreeBSD, they weren't hooked up.
Right.
Even the sharenfs wasn't. And so when it did start to work, there was no compelling reason to try and use it. It was just, that's a Solaris specific property, never mind. Pretend it doesn't exist.
And if it's going to be implementation defined on how it's parsed and whatnot, then it sounds, to me, it sounds like it should be linux.sharenfs and freebsd.sharenfs and so forth.
But then
yeah, and if you can imagine, that would be a nightmare to maintain. If you create a NFS export on FreeBSD, then you have to look up the correct export syntax for Linux and put that in as well, even though you're not using it. You might very well just go, forget that. And then 2 years later, when you move your pool to Linux and NFS shares don't work, why is that again? I mean, it always seemed a lot more practical just to pretend the property didn't exist. And this just seems like one of those properties that no matter what you do, it's, whether you have multiple properties for multiple OSs or a translation layer, like it just seems like it's always going to lead to sadness.
Do we have a strong advocate on the call?
Advocate for what exactly?
For this whole concept of file system awareness of the different sharing types, which may mean different daemons, which may mean porting daemons to Windows, who knows? It is indeed, as Josh put it, a long slippery slope.
Yeah, doesn't really, I mean, I think that it's worth doing something to make sure that the wrong thing doesn't happen when you import a pool. But I don't think, like in Illumos, we're not going to take it away because people do use it.
Yeah, I think that, I mean, from what I'm hearing, it sounds like the sharenfs property is not widely used on Linux and FreeBSD. So
it's at least somewhat used on FreeBSD.
Okay.
It is. I can confirm that. We use it quite a bit.
And so do we here.
Yeah, I would say it's used on Linux too, but only for like the most basic configurations, because we try to do that translation. If you want to do anything somewhat complicated, it's just not going to work. It's easier to use the normal tools.
Kind of along those lines, Brian. So if it were more Linux specific, do you think that it would actually have more value? Like, would people use it if we actually had sharenfs properties per platform, so that it would match the implementation on the platform you're using it on?
I think there would be a group of people who use it, but I think most people who come across it on Linux find it surprising that it even exists and that this is a thing the file system is aware of. So certainly we get requests for it, but I'm not sure it's critical functionality.
I mean, I think that
it's a question of usability there. Like with NFS v3, where you have to share each individual file system individually, if you have 200 file systems, being able to share NFS once on the parent and have it automatically inherit and configure all of them is useful versus having to manually write 300 lines of export file.
Yeah, and to maintain that as you add new file systems and destroy old ones.
Also, property is much more better if you want to migrate your pool between platforms. For example, if you have a pool on FreeBSD and iSCSI targets, you can move it to Illumos and save a NFS property, just for example.
Well, I think was Joshua's point, and I think he was right that I bet if you import an Illumos pool on FreeBSD with the different syntax, it will cause mountd to refuse to reload its config file because of a syntax error, and possibly take down other working NFS shares just because you imported a pool from Illumos that contains invalid syntax for NFS.
Yes, Alan, it was just for example where we can use it and where we will have a benefit if we have the same share properties.
Yeah, I mean, I think that's why George brought this up to begin with, is like the current way that it works is wrong, right? Like it is not right to be putting your Illumos specific things in this property and then like having Linux or FreeBSD try to interpret them. So we need to decide if we're gonna, like, we could just say, hey, sharenfs is Illumos specific. Like you put an Illumos string in there and other platforms should ignore them. Like that's fine. And then we could invent new properties for Linux ones, or say, yeah, sure, if Linux wants to figure out how to translate every single way of doing it on Illumos and have it do the equivalent thing on Linux, then that's okay too. But the string in there is specifically an Illumos share string. Like that would at least be correct. But I think we're trying to figure out, like, is there a better way to do this?
Matt, can we actually do that? Because it sounds like FreeBSD has FreeBSD specific strings in that pre-existing property name, right? So like we would, like that if we made that assumption, then FreeBSD would break, right? Because whatever their users are.
I mean, in the way that it's figuring out how to get there from here is, I think, another question.
Okay, all right, yeah, that makes sense.
Yeah,
it could be like, sure, we leave this behind as the deprecated, like just don't use that property, and there's a new sharenfs.illumos, sharenfs.linux, or like a new sharenfs.zfs that has its own new syntax that each platform has to figure out how to do it.
Or it's not a property anymore. Maybe it's a top-level command like ZFS share or something. Like, and you could create a whole new surface area for abstract level things that would be stored in properties underneath. But you could provide a UI for doing that if that was important to somebody. I think it's probably a mailing list level thing. I think at this point, though, It sounds like
Definitely.
we all agree that this is not correct today.
Yeah, I mean, there's some properties in NFS that map fairly well, like Linux has no root squash, and you can emulate that with FreeBSD's maproot, but like Linux has the FSID option that FreeBSD doesn't have, and so that translation layer is going to be really challenging.
Yeah.
So
I
George,
personally don't think.
Sorry, go ahead.
I was going to say, having looked at the translation code before, I don't think that's practical. I mean, there are lots of different options I noticed on the different platforms that just don't exist. So doing any kind of translation is going to be spotty at best. So my feeling is it would be good to steer clear of that.
Yeah, George.
I know we do it at Linux at the moment, but it wasn't a good idea.
Yeah, we ran into that. George, do you want to kind of give like our slant to like what we would like to see?
Sure.
We ran into that, what you just said, and we were like, well, that doesn't work for us, and now we're trying to figure out what to do.
Yeah, I mean, like, so given kind of our model, we actually relied on the sharenfs property very heavily in our appliance, and we're now kind of in that mode as going from an Illumos to a Linux engine of what do we do with this type of migration? How do we actually address that? We've actually considered saying, okay, well, let's at least make the properties that we use as robust as possible on Linux so that it just works, and then there is no migration that needs to happen. Or do we go off and kind of create some migration utility that is going to slurp in the properties and then write them out just using Etsy exports? So we're kind of in that world of like, how do we deal with this? The portable pools that ZFS provides is great, but there are these kind of nuggets that have been left around that have become very specific to certain platforms and don't necessarily make sense. And so we need to, we have to address it one way or the other. And so we're trying to see like what the community would like to see and see how that kind of, guides us as well.
Yeah. So, I mean, we're not, sounds like there wasn't a strong consensus on one thing. So George, do you want to take the action item to kind of write up, one or two proposals and send us to the mailing list, and then kind of lead that discussion on there?
Yeah, I'll send it out, and if people have feedback on, how they're using it, or it sounds like there's kind of a mixed bag on its functionality on platforms today, even if they were platform specific. So if you do have more feedback, I'd love to hear it. So feel free to reach out.
Mm-hmm. Cool. So let's move on to the next item, which is persistent L2 ARC status. I forget who requested that we talk about this, but I went trying to look for what the status is in my email, and I had to look a long ways back. This is a feature that I would love to see in ZFS everywhere. I spent a bunch of time personally doing code reviews for it several years back. But I couldn't find any activity on this in the past 2 years. In fact, the only code I could find was on a now dead server, a review board server. So I guess this is kind of a question for folks like, is this important to people? And if so, is anybody planning to work on like getting this code back up and running on any platform?
So we at Datto have talked about this a little bit, and maybe not in the context of actually planning on working on it, but more on just the limited helpfulness that the L2ARC provides in general right now. And so to us, I think one of our big things that was preventing us from putting it on our list of things that we might want is that since the L2ARC itself just isn't that helpful at the moment, making it persistent doesn't really add to it being not so helpful.
I think it's a minimum required feature for it to be useful, though, because the reason to have the L2ARC, in theory, is because without it, you are not able to fit the working set of the thing that you're trying to use on your giant pool into memory that has a low enough access latency for reads. And if a reboot or a panic or a device device removal or whatever, like can just kick out the entire contents of that cache, then that cache is cold again. The fill rate is not that high. And it could be like, if that cache being warm was a load-bearing part of your system's correctness from a performance perspective, that you might be like pretty screwed up after that.
Yeah.
Right, but my one thing is, it seems like Metaslab allocation classes would, for a lot of use cases, help alleviate this already. Maybe not make it, it's maybe not perfect. Like maybe if you have some, like a bunch of actual user data that's, you know, accessed over and over again, that, you know, and that you have on your regular spinning disks as opposed to your SSDs, you know, that's like a separate thing. But I think that some of the people who have this problem where, you know, they need an L2 ARC to make their stuff, you know, just to make their pools kind of go faster. I think some of that would be helped with like SSDs for metadata caching and things like that.
I mean, I think that both of what you're saying is like, that's what Josh and what Tom is saying is not mutually incompatible. Like, I think Tom's saying, like, we don't care about persistent L2 ARC because L2 ARC in general is not useful to us. And Josh is saying, like, if L2 ARC is useful to you, then you kind of need it to be persistent.
Yes. Like we were looking at it for giant Postgres databases where the working set was, you know, 5 times the size of RAM in the system. And like the reason we were looking at it is because the system was unacceptably slow. And so like if it was going to consistently dump itself on the floor every time the box rebooted, then it would become unacceptably slow again after every reboot for possibly weeks. Like it's not, but with persistence, it might be worth looking at. So.
Yeah.
Do people think with the improvements on, you know, sizes of SSDs, sizes of NVMEs, that it's becoming less and less a feature that's required? Because literally the underlying pool is on that level of storage.
Tiered storage is still a very popular theme I'm seeing. Of course, I'm mostly dealing with pools that are up to petabytes now, and then have, you know, tens of terabytes of flash, and often done as 2 separate pools. And that's why I've been interested in having per pool and per VDEV properties to be able to tune those rather than system-wide. But I don't know that we can just punt on the concept of L2 ARC and say, if you need the speed, you'll just have your entire pool be SSDs.
I think it depends on how big the thing that you have is and how big the working set is and how much money you want to spend on it. I mean, there are a lot of economic knobs that like I think it's true that 2.5-inch spinning disks are probably not that long for the world, and that form factor will probably be SSDs only. So
it's some of my customers are having trouble buying spares for 1 terabyte 2.5-inch drives because they just don't exist.
Right. So like that specific economic case will probably go away. But like if your data set is stored on 3.5-inch disks or SMR disks or some other kind of storage that's slower because it's cheaper at the capacity that you want, I think that the hybrid stuff is still going to be useful for some things. So.
Yeah, I work with a customer who's gradually moving to the large amount of storage, so they're still using the spinning disks of the highest capacity available at the time, so 10 or more terabytes. I'm not sure what they're up to now. But yeah, they'd be running with a couple of NVMEs as the L2 ARC. This is using the Oracle Solaris at the moment, but that was absolutely essential for their workload. So if somebody wanted to do something similar on a Lumos, I would guess you'd need the same sort of layout.
It sounds like this is persistent L2 ARC is interesting and potentially useful to several folks. Is anybody like thinking about potentially making this a priority to get it in, or should we just kind of continue status quo for the time being.
Sounds like status quo based on the lack of comments.
Yeah, I think we need to, in our code at least, we need to focus on importing from ZFS on Linux first, I think. So that's going to take a while to get done. So
Feature is interesting, but how much time we can spend on it, it depends on our business work.
Yeah, that's fine. I mean, everybody's got priorities. Cool. So let me reorder slightly. Let's go to trim support. So several folks had asked me about trim and having a discussion about it here. So background, there's a trim implementation in FreeBSD that is not in any of the other implementations. And then there's a trim implementation that I think it came from Nexenta originally on Illumos and has been ported to ZOL Linux as well. So I think folks wanted to talk about both like should we have both of these? Should one of them become the standard? And also what's the status and what's the path? What are the next steps to get one of these actually integrated onto the rest of the platforms?
Is the trim one for Linux like working, finished?
Yeah, further no. Jerry, do you want to go ahead?
Oh yeah, the one that Nexenta did that I ported it over to the latest and I emailed out about it last fall is working. And I thought that was going to be lined up with the ZOL work, but I'm not sure because it sounded like Tim Chase was maybe thinking of going off in a different direction now for trim. So I don't really know if that's going to, I mean, I want to stay in alignment with whatever ZOL is doing.
Yeah. Tim on the call? If not, I can talk about it.
Jerry, I'm using your version from Joint 3 for DOS, and it's working as well without panic. And I confirm it on your review board. I think you can upstream it.
Yeah. I don't see Tim on here. So,
okay. So trim has an open pull request against Linux. We've had one open for a couple of years now that keeps getting rebased, but it has yet to be merged. So I think this is a really good question because one of the things that's kept it from being merged is we want to do the same thing as all the other ports. We didn't want to diverge in our own direction. So if there's general consensus that the trim implementation from Nexenta is the right way to go, then I would like to get that integrated for Linux.
Is the trim one on Linux? I'm looking at pull request 7363. Is that based on the Nexenta stuff, or is this yet a third implementation? Oh, this looks like it is based on Nexenta stuff.
It is based on the Nexenta stuff. I know Tim just got it rebased again yesterday, I believe. I was working on it.
So then it sounds like Illumos and Linux are both kind of looking at this from Nexenta implementation. Maybe there's minor differences that we need to sort out between them.
It's actually confusing for the ZOL stuff because there's two different pull requests. There's 7363 and 5925, and I'm not really sure what's going on with these two different ones.
They're the same code. Let me look again. They're the same code. They're just rebased against different parts of the tree. One's an older version against the release branch. One's against the current development branch, if I remember right.
Can we close the older one?
If it can
let me look into it. Figure out
can,
which one to close, but yeah.
If it can help, I can publish a version what I ported to Delos from Joint 3. It's public URL.
Because I think on the FreeBSD side, we'd like to see that as well, as we're in the process of moving to being based on the ZOL repo. Trim is one of the features we're hoping we wouldn't lose as part of that transition. So if we pull in the Nexenta one via ZOL that way, that makes our transition easier.
Okay.
Yeah, indeed. No, it's been in our tree for a long amount of time. We use it excessively here, but well up for making sure that we've got the right resources around getting it into to Linux and then into FreeBSD and making sure that we're all on the same page on that one. I definitely don't want to be supporting two different implementations moving forward. How we actually do the migration between the two, obviously that's up for debate. But focusing everybody's efforts on one consistent implementation is definitely going to be the way we've all got to go on.
I guess a slightly related thing that came up in FreeBSD the other day was the possibility of initialize or a version of initialize that would trim the free space for pools that didn't have trim before, but will have it once this feature is integrated.
We do actually have that, Alan.
In FreeBSD?
Yeah, it's been there since year dot. There's actually a sysctl to control it as well. So basically,
well, that's trim when you add the device to the pool,
or when you create the pool itself.
Right. So the initialize command is, I guess, usually used then, but could be used later, like for existing Linux pools that are on SSDs but have never had trim before.
Yeah, quite possibly. Yeah. That could be done.
Basically, a version of initialize that just does trims instead of writing zeros.
Well, what happens with Linux on like non-ZFS file systems is there's a fs trim command that you can run arbitrarily. So instead of running continuous trim, which on some devices can hurt your performance significantly, the fs trim hooks into the file system, and then it finds large chunks of free space consistently with file system activity, and then runs trim on the empty space, so you can run it after the file system was created.
Does that work with ZFS?
Nexenta's implementation actually has a concept of manual trim, which sounds like what you're describing.
Yeah,
that's right. You can do it either way. You can have it trim ongoing, or you can do a manual trim, or you can combine. You can do both. So the Nexenta code does have both paths.
Yeah. We did look into using the initialize code for doing trim, but I think the general consensus was that it wasn't quite sophisticated enough to address the performance concerns you guys were talking about, where you could issue the trim commands, but a lot of work was done in the Nexenta trim version to optimize that so you don't hurt the performance, to better batching, better aggregation, that kind of thing.
Is that the initialize code could be repurposed to do trims, but it would be a one-time, like one-time only kind of thing. Like we go find all the free space and we trim it out. But the Nexenta trim code can do that, but it can also do ongoing trim where it's keeping track of like recent frees and then aggregating them together and then issuing those kind of continuously to the disk.
Right. Sorry, I didn't know I had that extra feature. So never mind.
So it sounds like there's general agreement that we should go ahead with the Nexenta version of trim. Does anybody object to that?
So I agree. It sounds like folks are behind that. I have kind of high-level questions about that code and how it's working. Jerry, you probably saw my emails about there's a lot of complexity there about keeping track of frees and aggregating them and how that interacts with allocations. So I'd be interested to hear like anybody's experience with performance of this. Like ideally, I'd like to see like somebody say, okay, like if I don't have trim, we get this performance and it's bad. If we do have this trim code, we get great performance. And if we have the trim code, but we turn off all the fancy complicated stuff, then and maybe like we're just trimming every TXG, what was freed that TXG, then we get better than baseline, but not nearly as good as the full implementation. Like that to me would kind of justify the the complexity, code complexity of the.
Yeah, we're not running this code yet in in our source because we're waiting to sort of get some clarity on where things are headed. I don't know if anybody's available from the Exenter, or maybe we could ask again, like on the mailing list, because I assume they would have the most long-term experience with performance. But I can't really say sort of what the different trade-offs are because we're not running it yet.
Mm-hmm.
Well,
we've had a lot of
from a standpoint, a lot of modern SSDs don't need trim to keep their performance up anymore. While it used to be vital to trim SSDs to keep their performance from absolutely tanking, these days it's more about reclaiming space than it is about performance. So from a enabling trim standpoint, you really only stand to lose because there's a lot of devices, and this is just in the locally connected block device arena. They get very unhappy if you start to trim them too aggressively. As soon as you start talking about network block devices like a SAN or something, well, VMware, they turned it on for a little while and then, oops, we better turn that off because you can really make SANs unhappy if you issue trims to them. So this to me isn't about performance at all. It's more about reclaiming space. And from that aspect, I would be very conservative if I had anything to say about it.
I don't know that I would say trim is not a performance issue. I mean, I know that in the testing that we've done on it, or like Intel NVMe devices, and we did it with ext4 and we did it with ZFS, and having trim enabled lets you keep consistent performance over a much, basically steady state, right? And without trim, after the device has been overwritten once, your performance starts to decline as it still does have reserved space, and the FTL can, find erase blocks and things, but it has to do a lot more work to do that. If there's lots, the file system is telling it that space is unused, it doesn't need to do work to reclaim it. Right, so it is still a performance issue, even with the fastest devices today.
It feels like it could also have an impact on durability for devices where there is less oversubscription, or rather more oversubscription between the advertised size and the physical flash cell size underneath. Does anybody have any experience with or knowledge of the impact that trimming or not trimming has on the wear leveling stuff that the SSDs do?
It has a fairly significant impact. This is from experience with Apple. The big issue with trim that we ran into, and this is several years old, so things may have changed, but the big issue was trim has a particular overhead, so you need to be smart about how much you issue and how you integrate it with the rest of the I/O flow. I think Apple limited it to 8 simultaneous commands at a time, and then queued any further, waiting for other I/O to be done.
But I mean, it can also benefit, the wear leveling, because you don't have to the FTL is not rewriting sectors that it thinks are in use. Right? It can just discard them instead of packing them together into other, erase blocks. Right?
So
I mean,
we've had a lot of people.
Sorry, I was just going to say, there's definitely a danger. I know, like ext4 has, the online trim, and my understanding is not many people use that. Right? It does, we do have aggregation. The initial trim everything that's deleted, was a disaster. And so we do have in ext4, there's a tree, and it aggregates and things like that. But even that is still, and devices have gotten better, but I think the more common case, unless you're, overwriting your whole device every day, I think the more common case is, you run trim once a day, and that's enough, unless your file system is 99% full all the time.
Well, if it's full all the time, you wouldn't need to trim at all.
Well, you'd need, I guess that's true too. But if you're very close to the edge, then you want to free up the space to avoid waiting on the erase block packing, right? But if there's lots of space, then you do it periodically. You get minimum performance impact, right? And so there is a question in my mind whether the online is beneficial versus just having a periodic trim out unused space in the file system.
To give some
the complexity is all in the ongoing trim. If we only needed a periodic go trim out all the free space, then that would be much simpler implementation wise.
To give some historical information, obviously we sponsored the original trim FreeBSD work because of the performance issues that we were actually seeing. Obviously the disks and vendors have improved significantly in that space. But in all of our implementations, even since those improvements, we've all found that the full online trim was beneficial in 95% of cases. Now, I don't know how other people's experiences, but it's been the default of on in FreeBSD since that point, which has been years now. I've not seen any major objections to the performance degradation, and that there have been some, and we've made improvements over the years. But in terms of actual, if we were to go to, got to go and schedule it, I think that would be a definite step backwards in terms of performance and supportability.
I can say, I'm sorry. I can say from my own experience that over the past years, consulting freelance users, a number of times I recommended to disable trim to users of different consumer SSDs, because in many cases, in case of rewrite, when writes was combined with synchronous, with close to synchronous trim of FreeBSD, performance degraded, and disabled trim actually helped. On the other side, just recent days, our performance engineers run some tests, maybe not very deep, but at least with a couple of SAS drives. And for Western Digital SSDs on the test, trim gave no any visible benefits, probably due to efficient enough FTL of the device. But on much cheaper Micron SAS SSD, trim actually improved situation a lot, at least on scenario of sequential file rewrite. Maybe on random access or other results could be different, but at least on sequential rewrite, trim significantly improved performance, reduce the degradation, which otherwise Micron SSD shown. So I would definitely like to have ability to do trim asynchronously, while I still assume that there could be devices which could benefit from synchronous implementation. And as mentioned, for NASes, for VM storages, it could be also interesting from point of space reclamation, space reuse.
So the thing with the Exenta code is, right, if we go down that path, we have the choice of all these things, right? We don't have to use it. Right. We can have it used on an ongoing basis. We can have it used when you initiate the command, however you, either by hand or in a cron job or whatever. So, we have all these choices if we go with an Exenta code, but right now we have no choices.
Yeah.
So
the Exenta code doesn't support all that.
Yeah. So to be clear, my request for performance information was not that it needs to improve performance in all situations. I totally agree, Jerry, that having the feature set of that code is large. I guess I was kind of looking for somebody to say the feature set is large, and in this use case on these drives we really need it. The implementation complexity is justified, in at least some cases. My concern is that, I don't really want to take this code just because it exists and it checks a lot of boxes, and and have to deal with the complexity forever.
Yeah.
So
I have a suggestion and question.
Mm-hmm.
Would it be possible for someone to come up with a short write-up of how the Nexenta and the FreeBSD versions of implementations of trim and ZFS work? And then we can try to figure out a way to compare them and decide which one, if either, would be the way to go.
I think we can try to integrate a joint version of trim, and this feature can be disabled if you don't want to use it. It's fine. It's fine to have this feature, but if you want to use it, you can enable it. If you don't want or have some performance degradation, you can disable it. It's fine.
Yeah, I mean, I think it would definitely be off by default. And that's how the code is being proposed currently, as far as I know.
Yeah.
Matt's point is about the added complexity cost and so on. Like, I know the FreeBSD version of trim has been the source of 5 or 6 bugs as we've integrated new features like device removal. There were assertions in there that said that this device would either receive a read or a write, and it didn't understand what a free operation was. And a couple other places where trim had assumptions that didn't apply elsewhere, and I'm sure the Nexenta version has the same kind of complexity. And I think Matt's point is that the question isn't whether we want the feature or not, is whether it's worth the complexity.
Yeah. So to your point about performance and complexity, Matt, yeah, we definitely have had situations where the trim functionality was needed to make a pool perform properly. It depends a lot on the exact hardware being used, but we have had people test the pull request and verify that, yes, with this, I don't see my performance crater after several drive rewrites. Without it, it does. It depends a lot on the exact hardware, which is what everybody said. So
that's with the Nexenta based patch to the Linux ZFS? Okay.
Yeah, we've been carrying it for a long time, and it's probably our most requested bit of functionality, and people keep picking it up and testing it, and we get a lot of anecdotal information back about, yes, this does solve my problem. But I mean, the test base for it is so large, right? Because it depends on exactly the bit of hardware you're testing with.
And that's what we saw with FreeBSD. It was very specific to the hardware, but not only the just hardware, it was very specific to the access patterns that were occurring at the time as well. But it did make the difference of, actually, you know what, I need to take these SSDs and hardware erase them every 3 months to get them back to use the amount of performance, versus we can just forget about it. And when the disk runs out of steam, it runs out of steam. But for 99% of the time, or 100% of the time, until we actually started losing disks, it was perfect. We got the frame implementation in.
Yeah, there's no doubt in my mind that the older the SSD is, or the lower end it is, the more trim helps it. I mean, in a 2007 era, Intel 710 or 310 was unusable without trim. I mean, it would turn into a disk drive very, very quickly. 2016 or 2017 era SAS SSD, it's almost more trouble than it's worth. You have a greater chance of locking up the firmware because you sent it too big a trim than getting a performance improvement out of it. So
those SAS SSDs are already, though, expensive enterprise SSDs with higher durability and a bunch of other stuff. Like, they're just much more expensive, even today, compared to the lower end stuff.
Yeah, and I think SAS SSDs are going away anyways as NVMe takes over. But my point is that, definitely whatever implementation we use, you need to have the option to turn it on or off. And so I think the complexity is warranted if you're going to have it, because you're going to want to be able to do online and offline trim.
Does the Nexenta one let you control like the queue depth of the trim commands?
Yes, I believe it does. It also lets you control like the minimum size it'll issue for trims, so you can skip small holes and that kind of stuff.
Because I know on FreeBSD, that's one of the main things is depending on, certain consumer drives don't like it when you give them 64 outstanding trims, and enterprise drives can't keep up with the amount of trims you're doing if you don't give them at least that many, and so on.
Yeah.
Yeah, it'll manage. It'll allow setting the minimum and the maximum size, and it runs in the background, so it can schedule across, multiple devices and things like that.
Right, and does it have? But it has like the VDEV QDepth controls like we have for, asynchronous reads and initializes and resolvers and so on.
Yes, I believe so.
Okay.
But
the only feature I haven't seen on it, Alan, is the ability, or I haven't confirmed on it, is whether or not if you've got a mixed pool, it performs as it should, i.e. send the trims to devices that support trim and doesn't send it to ones that don't.
Yes, it does that. It detects if it supports it, and it won't send it to the ones that don't.
Cool.
Has anybody had a need to trim like L2 ARC devices?
The FreeBSD one does that.
L2ARC would be mostly like, because it's written sequentially.
Sequentially, yeah.
You would think that there would be no need to trim it because it's all sequential writes. It's going to be used all the time, basically.
That's one of the reasons you would want to trim with an SSD.
What reason?
If you're doing writes constantly, even if they're sequentially, it's still going to have to remap, especially when you start filling up the device and reusing blocks. The purpose of the trim is then to allow that to do that more quickly.
I think that's when it becomes critical, doesn't it?
But I think the point, L2 ARC generally, at least under a lot of conditions, you're never going to remove any data from it.
Right, it's always an overwrite in place. Right?
Until it fills right up, at which point you would have an eviction policy.
I think one of the other features of, I think, both trim implementations is to delay trimming a block for a little bit of time so that if we do overwrite it, we don't have the waste of free it, trim it, and then immediately write it again, because then we could have just overwritten that LBA and the flash wouldn't have had to do anything.
My impression was that the goal of that logic was more to aggregate the trims so that if you free adjacent things in subsequent transaction groups, then you get to issue one big trim. But that's also where a lot of the complexity comes in, where we need to keep track of things that were freed in the past, and then if it is allocated later, then we have to remember to not trim it now. So
we're almost out of time.
Yeah.
We have an auto trim option and manual trim option.
Yeah, those options exist.
And we can manage it where we need it. If we need after trim, we can enable after trim. If we want to use a manual, we can use it a manual periodically.
Yeah. So to kind of, sorry, did you have an additional point there? I didn't mean to cut you off.
To make one point is on the actual device support. Obviously, as in the FreeBSD stuff, where it comes down to the device layer, we did end up having to manually ensure that individual trim requests didn't get too large, else the performance on various drives just plummeted. So just to make people aware of, if the OS at that layer doesn't support to go, oh, you know what, I'm not going to issue a trim greater than, say, 64K, 1 meg, 10 meg. If it doesn't have that ability to limit that you may see some significant performance degradation at that layer as well.
And size is one of the tunables.
Yeah. So it sounds like there. I'm going to give one last chance. If anybody that I cut off would like to continue their thought, go ahead. Then I'm going to conclude. Okay. So to summarize trim, it sounds like there is a need for both periodic trim and ongoing trim, perhaps different needs. The code does that. People like that. I think my concern about the complexity still remains, but it's good to know that the performance does, like, it does improve performance, anecdotal, like in actual test cases. So that's good. I still think that like keeping track of all the trims across a bunch of TXGs and whatnot is a lot of complexity that may or may not be needed to achieve that good performance. I'm glad that we're kind of a little bit more on the same page as to what functionality the code actually offers. I think maybe in the future, it might make sense to, when we're discussing these projects, to have somebody lined up to give an overview, since obviously not everyone is on the same page about what functionality there is in the features that are under review. So so just that we can get on the same page more quickly rather than kind of haphazardly. Next time, I guess we'll continue with the agenda items here. There's still a few more features that folks would like to discuss. Any other agenda items, put them in the document, or let me know now. Does anybody have things they'd specifically like to get to next time? All right, great. Well, we're on time. We stayed on the agenda, so I'm glad about that. Next time we'll talk about redacted send and receive and the pool features, default pool features that we started discussing last time. Also, just so I can remove this from the agenda, Alan asked that anybody using LSI HBAs with a lot of SSDs or NVMEs on FreeBSD to contact him. His email address is in there, and he's also on Slack, Alan Jude. Was there anything you wanted to add to that, Alan?
No, it was just looking at problems with the driver on FreeBSD.
Cool. All right. Well,
when you say a lot, Alan, what, are we talking tens or single digits or?
Yeah, tens or so on a single controller, but enough on one controller that it saturates the interrupt thread, basically.
Okay.
When you're having performance problems because you have too many SSDs on one controller and the controller isn't multi-queue.
Yeah. Cool. All right. We're also getting kicked out of our room. So thanks everyone for attending, and we'll see you in a month, in 4 weeks. Bye.
Bye. Thank you.
Bye.